Ready?
Should we be drawing all of these things?
Yep. All right. So here we have a distribution, a probability distribution for drawing numbers between 0 and 1. How did I know what it looked like? Well, I know all the numbers are equally likely to be picked, and I know the probability area under it has to be 1. It has to look like this, 1 over and 1 up. So that is my graph. So what's the probability of drawing a number between 0.3 and 0.7? So let me put in some reasonable tick marks. And you'll have to use a little bit of your geometry skills to figure this out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 0.3 is right here. And 0.7 is for 0.3. 0.7 is right here. So I need the area under this curve. So once again, I have a rectangle. If you could get now the width and the height of it, what will be the probability is that area. So what is it, mathematicians? What's the area that I've striped? 0.4. You notice the width is 0.4. From 0.3 to 0.7 is 0.4, and the height is 1. So the probability of drawing a number at random, any number between 0 and 1, what's the probability of it being between 0.3 and 0.7? The probability of that is 0.4. So that's how we're going to deal with that. A lot of our distributions are normal. They're not going to be like this. They're going to be normal distributions. And so we come ready and trained to deal with normal distributions. So draw yourself a normal curve. And let's say that we are looking at the heights of young women. Heights of young women. They have a mean, guess what the mean of the heights of young women are?
5'5".
Almost, 64 inches, which is 5'4". You were close. And the variance, so the mean is 64. So notice where,
How do we clarify what a young woman is?
yeah, I don't know.
Okay.
18 to 29.
Same in Napoleon.
I don't know. All right, they didn't say, so a little vague there. And you remember, the standard deviation is 2.7 inches. And you'll recall that if we go out one standard deviation from the mean, say right where the curve changes from a frown to a smile, you go 64 plus 2.7. 60, what is it? What's 60?
66.7.
Yeah, 66.7. What would the next one be? Could you calculate it for me?
69.4.
69.4. And could you go the other way for me? 64, if you go one standard deviation this way, you subtract it.
It'd be 61.3.
And then,
That would be 58.6.
all right. So we've seen that kind of thing before, but lots of times I will ask you for intervals that aren't exactly on those standard deviation lines. So if you recall how we did that, well, I'll get ahead of myself. What I want to say first is the heights of young women a random variable? Is it a random variable? No. It is not, because do you see any chance event taking place? So now I'm going to change it to a random variable by saying it like this. I'm going to choose a woman, a young woman. Now it is a random variable. Her height is a random variable because when I chose them, it became a chance event. And when I chose that young woman, she was chosen at random. So therefore, I've changed it subtly from a density curve to a probability density curve. So now I'm going to use what we learned in the past. I don't know if you still have these. I'll give you a new one.
Oh, I like
Thank you.
now that we are in continuous random variable land, we have to have some numbers to help us. And what is this, chart A, I think, in the back? So,
Table A.
Yeah.
A,
All right.
table A.
so I'm going to show you how to do one, and then you're going to do some.
Here we go.
So, I want to know, I have chosen at random a young woman, and I have taken her height, and I want to know what is the probability that this woman that I chose is between 68 and 70 inches. All right. The way we do this is exactly how we used to do it in chapter 2. We're going to change these numbers to what was called z-scores. So we're going to take the number, a z-score is the number minus the mean divided by the standard deviation. So I'm going to do a z-score for 70 and a z-score for 68. So when I do the z-score for 70, I get 70 minus 64 divided by 2.7, which I'm sure I
Ouch.
calculated that. 2.2. 2.2. All right, I'm going to put another decimal in. I think our chart will gather 2.22. I'm not sure. Whatever our chart will take, I'll take. And then I'm going to do it for 68. I got 1.48. So those are the z-scores. And if you recall, the z-score takes all this and changes this to 0, this to 1, this to 2. It standardizes everything. So I'm looking at 2.2, so that's pretty high up here. And I'm looking at 1.48, which is about here. So I'm interested in the area under the curve right there. So we have to go to chart A and find the area. The area is always to the left, below the value in the chart. So I'm going to get the area under the chart for 2.22, and then I'm going to get the area below 1.48, and I'm going to subtract the 2 to get this area. So go ahead and look up 2.22. I'm going to put a little arrow with chart A to show you where the number came from. Do you remember how to use it? Go down 2, positive 2. Is that on the back? 2.2, and then go over 2. So our chart will go over to 2.22. I got 0.9868. Do you get the
Yay.
same?
Yeah.
0.9868. And then when I do 1.48, 1.48, 0.906, 0.9306.
Yeah, 0.9036.
Ah,
Is it?
9306.
Oh,
0.9306.
oh yeah, it is.
1.48, yeah, 0.9306. All right, so this is an area. That's why I called it chart A for area. Minus this will give me the area that I'm interested in. When I subtract that smaller number from the larger, I got 0.0562. So when I'll put it over here, 0.9868 minus 0.9306 will give us 0.0562. So the chances of drawing a woman at random, young woman at random and taking her height is 5.62% chance of getting a woman between 68 and 70 inches tall.
Do we have to put in percent, or can we leave
No,
it as?
you do not. You may leave it as a decimal. All right. Your calculator can do that as well. So would you try it? I can't, your dinosaur won't do that, Elena. Does anyone remember, I couldn't even remember where to go on, was it variables? We're trying to use, I know there was a button on the calculator that would do this work for us that chart A did. And it looks something like this, but I don't know where to get it. Normal. And we want CDF. and we would give it the mean and the standard deviation. What was the standard deviation? No, we had to give it the intervals, 68 to 70. Then we give it the mean, which was 64, and then we gave it the standard deviation. And it should give us that same number, that 5%. But I don't remember where to find that, and I didn't have my calculator to find it. Did you look anywhere? You couldn't find it? Did you look in stat? I think it's in variables. Maybe under statistics.
I went to stat and there's one variable statistics, two variable statistics. Line regular, that's what we did.
Didn't we do this?
Yeah.
What's various table? Alright, I'll have to look it up on better in the book. I tried to find it in the book and I didn't spend enough time doing that. Alright, your assignment is to exercise these things. If you would look at the homework, you'll see the reading there. That is not reading you have to do, but that's the reading these problems cover. So if you get to it and can't do a problem, look at those pages and it will help you. So notice it says 14, 18A. I forgot to say on 20 it's only part B and C. If you're not listening, you can do part A and you'll enjoy it. So on 20, just do part B and C. 21, 23, 25, and 26 are as stated. This will exercise this work. Now,
What note page is this?
where's my phone? I'm sorry? What's up?
Never mind.
Okay. So, here's this one. It's 20 part B and C.
Yeah.
Alright.
It's been 12 minutes already.
Alright, we're pretty much done. Alright, we're into doing homework now, so we're going to shut down this class and hope to see you next time. So, Over and out.
Trying to fit it. Sorry.
can you turn off the video?
Oh, yes.
Bye.
Goodbye, Julia. Sorry.
A long